Hey guys, I'm going to talk about graphing functions today. So what do the transformations of the parent functions, what actually happens to the picture of the graph when we look at different things um, or different parts of transformation. So if you think back, we had if the negative is in front of the function, then it's going to turn it upside down. The absolute value signs, again, that tells us that's a V-shaped graph. So we see it's a V-shaped graph and it's turned upside down because of the negative here. Okay? The -1 is going to shift it right 1. So if you think about the vertex of the parent function was here, it goes over 1, and then the +7 moves you up 7. So each part of this takes the parent function and shifts it to a new location, but this would still be found in the family of functions for absolute value because it's still the same general shape. It's just been reflected and shifted horizontally and vertically. So again, it shows you the parent function here, the most basic function, f of x equals absolute value of x. And then what it did was it reflected across the x. It translated right 1 and moved up 7. Okay? All right. We talked about the other stuff on the other side in the last recording. So this time we're just going to look at the shapes and what the equations do to the picture or the graph. All right, so this one is x squared. So this is a quadratic function. So the parent function would be f of x equals x squared. It has a 1/4 inside of the parentheses. Okay, so that's what's going to make it wider here than normal. And then everything else pretty much is the same. So it's just a horizontal stretch by 4. Remember, it's 1 over b. So this one is just a horizontal stretch of 4. All right, the next one, if you look at this and you say, oh, there's an x cubed there, that means your parent function is cubic. So if you take this other stuff away, you just have your parent function. But the 2 is going to make it a vertical stretch of 2, okay? Kind of makes it a little steeper. Sorry, the picture here is not very good, but these are kind of hard to draw. If you graph it on your calculator, it's going to look a little prettier. And then -5 basically takes the point that did go through the origin and shifts it down 1, 2, 3, 4, 5. Okay, so a vertical stretch of 2 just kind of makes it stretch out towards the y-axis a little bit more and then shifted down. All right, let's look at the square root function. Okay, I know it's a square root function because just a basic shape, it's like half of a quadratic. If it went all the way around, it would be a sideways quadratic, but this is a square root function. It has a 3 on the outside, so that's going to give me a vertical stretch. You see it's steeper than normal. Vertical stretch means it stretches towards that y-axis, okay? So a vertical stretch of 3. There's a negative inside the square root. Inside means it reflects across the y-axis. And then this -2 shifts it 2 units to the right, so it moves over 1, 2. So all of these numbers and signs just change the position and stretches it a little bit of where it is, but it's still a square root function. All right, this one is a cube root, okay? Cube root function. So the 2 on the inside, because it's on the inside, it would have been a b value. Remember, a was on the outside, b's on the inside. You can refer back to your other notes. So when it's inside, it's going to be a horizontal, and it's a compression of 1/2. Remember, again, it's 1 over b, and that was on the other set of notes that we have done. All right, you've done 2 things here. There's a +1, which means it's going to shift you to the left 1, opposite the sign when it's inside, and then you're going to shift it up 4. So again, if it were the parent function, it would have been going through the origin here, but because this is a transformation, then it's got several movements, same general shape, just been shifted around a little bit. All right, this is a rational function, okay? This one again has a variable in the denominator, so it's going to approach some number. You can see that it can't be -3 because -3 plus 3 is 0, and you can't divide by 0. So if you look, both of these functions here kind of approach the -3, but it doesn't touch -3. So if you think about that -3, see if I can highlight that here. 1, 2, 3, -3. See how that line kind of approaches that? And it kind of approaches it down here as well, and it's not actually getting to that. So that's where your isotope would be. All right, so back to the transformation. What's it going to do? This negative is going to reflect it across the x. Okay, so it's kind of reflected the opposite direction than normal. The 4 is going to be a vertical stretch of 4, and then it's shifted to the left 3, and if it's shifted to the left again, that makes that a +3 right there. So a little bit to think about. All of these are just a little bit different, but all the transformations are doing something similar to the graph. All right, another cube root function. Again, we're just looking at the shapes of the graph. Cube root function, okay. Normally, the cube root goes like right through here somewhat, okay. So it looks like it's upside down. That comes from this negative inside the radical sign, okay. So the negative inside the radical sign flips it or reflects it across the y-axis. And the 1/3 is inside the radical. Again, that's a b value. If you look on your other notes, you'll see that b is the variable we use when it's inside. And that produces a horizontal stretch by 3. Okay. And then this whole graph, if you look 1, 2, 3, 4, the whole graph has been shifted up 4. So it's been translated up 4. All right. Again, you can take these and graph them in your calculator. You can graph your parent function in your calculator as well. It's good to graph both of them and see what the original function looked like, and then see what the transformation looks like beside of the original. That way you can see that they're the same basic shape. They've just been reflected or shifted to different parts of the graph. I hope this has been beneficial to some of you guys, and I hope you do a great job on your project coming up.